We've made this film to help electronics engineering students understand how a PCB is made easily and cheaply. Designing boards that fit within industry standard specifications gives you two advantages. You keep down the cost of your end product so that it will sell better, and you improve its long-term reliability so that your customers will keep on coming back to you. And when you want to push the boundaries of technology, and who doesn't, you can sit down with your chosen board manufacturer and discuss your requirements, knowing where he is coming from. In this film, we will show the manual processes of PCB production. Single and double-sided boards use some of these, but not all. PCB manufacturers don't make each individual circuit by itself. They combine several circuits on a large production panel, which is much more efficient to handle through the factory. Different designs on one panel, as this allows us to make small quantities of different PCBs cheaply and efficiently. Board designer has prepared his layout on a computer-aided design or CAD system. Each CAD system uses its own internal data format, so the PCB industry has developed a standard output format to transfer the layout data to the manufacturer. This is extended Gerber or RS274X. The Gerber files define the copper tracking layers, 4 in the job we are following, as well as the solder masks and component notations. First we check that data meets our manufacturing requirements. These checks are mostly done automatically. We check the track widths, the space between the tracks, the pads around the holes, the smallest hole size, etc. The engineer can also check and measure individual areas where he wishes. Once the data is verified as good, he will output all the tool files needed to drive the machines that will make and test the PCB. Preparing the photo tools. We use laser photo plotters in a temperature and humidity controlled darkroom to make the films we will use later to image the PCBs. The clean room uses yellow lighting as the photoresist is sensitive to mist. The operator checks a sample of the panels to make sure that the copper surface is clean and all the unwanted resist has been removed. You can now see in the blue resist what will be the copper on our inner layer panel. Register punch and automatic optical inspection. The inner core of our multi-layer is now complete. Next we punch the registration holes we will use to align the inner layers to the outer layers. The operator loads the core into the optical punch, which lines up the registration targets in the copper pattern and punches the registration holes. We won't be able to correct any mistakes on the inner layers once we've assembled the multi-layer, so we now give the panel a complete machine inspection. The automatic optical inspection system scans the board in broad strips and compares it with the digital image generated from the original design data. Any errors are displayed on the screen. Once the cycle is completed, the press operator unloads the press and carefully rolls the heavy stacks into the clean room. Here the layup operator deepens the stack and removes the top plate. He unloads each of the panels from the stack, removing the aluminium press plates used to ensure a smooth copper finish. The copper foil is now bonded in place to form the outer layers of the PCB. Electrical test. We electrically test every multi-layer PCB against the original board data. Using a flyer probe tester, we check each net to ensure that it is complete, no open circuits, and does not short to any other net. The flying probe tester is easy to set up as it doesn't need to test fixture, but testing every net is slow. A faster test method is the Acceler 8. This uses 4,000 tiny probes like a brush. It builds an electronic map of the PCB from a preheated good board. Then it compares each board to be tested with its map. This cuts test times by 90%. In the last step of the process, a team of sharp-eyed inspectors give each PCB a final careful check over. Here, an inspector checks a customer's assembly panel. She looks for any cosmetic defects like scratches. Then she measures the panel against the mechanical drawing, checking hole diameters with a tapered probe. If everything is okay, she prints out the production release note. After inspection, the PCBs are vacuum sealed to keep out dirt and moisture. Then they are bubble wrapped, securely boxed, sealed and shipped off to the customers throughout Europe by overnight courier. The process is complete. We have followed our PCB from the customer's original design to be assembled into his finished product.